New to us here, we're going to be discussing logarithms. And it's just a very funky way of writing an exponent. Seems kind of strange, but there's a method to the madness here. So when you're looking at an exponent, we have a base, okay, and we have an exponent, and then you get an answer. So I mean, we're used to things like 3 to the 4th power equals 81, things like that. When you write it as a logarithm, all three of those pieces are still there, except they're in different places. Now, your base becomes this little number down here. It's called a subscript. So that comes in down here. Our answer is right next to it, and then we equal to the x. You're like, okay, Hardy, this is weird. Like, why do we need to do this? Because there's going to be some problems that we get into that's going to actually make it easier for us to do. So here's how this works. If we want to write a log in exponential form, especially if they're in numbers, this makes it easier. So I'm kind of comparing here, and I go, okay, so so that's my base, so b is 3, so okay, so 3. Then a is my answer, okay, so that's 2. And then this number here is next to that. So does 3 to the 2nd power equal 9? Yeah. So that's what I like about looking at these this way, because now I know if my answer is right. Like if I'd have put 3 to the 9th power equals 2, that's not right. And so I would even suggest that if you struggle with this a little at the start, maybe you look at this and you go, okay, so b is 6, a is 216, and x is 3. And then I just look straight at the form. B to the x power equals a. Just to show you that I'm not crazy. 6 to the 3rd power is 216. So sometimes that's going to be kind of obvious with those. So I mean, if I look at this next one, I'm like, okay, and we won't do all of them, don't worry. So I got b, so there's my b. And I kind of just keep looking here back and forth. I'm like, all right, so b, that's a, that's the answer. That's the exponent. 7 to the 0 power equal 1. Yup. And I work those through. This works not only for whole numbers like that, it works for fractions too. So now this is where it gets a little more interesting. There's my base. This is always going to be my exponent. This is my answer. Now that one may not seem quite as obvious. I'm like, math enter? Okay. But here's the real reasoning behind this one. Because again, remember, 4 to the negative 2nd, we're going to flip it. We don't like negative exponents. And 4 squared is 16. So that's how, again, I can check that one and know that I'm doing it correctly. Even if I look at myself with that and go, I don't know if I can know that one off the top of my head. Base, exponent, answer. 9 to the 3 halves is 27. Okay. Like I said, if need be, especially this first day we're doing it, if you need to look at your form and write BAX and then just start substituting them in, do it. If you come up to me and struggling, that's exactly what I'm going to suggest that you do. And so we also, though, are going to want to go the other direction. If I have something that's in an exponential form and I want to do it in a log, this is going to be trickier because I don't have my forms on the screen. But I look and I'm like, okay, let's just say I use this as my example. My b is 14, my x is 2, My A is 196. And again, Hardy, where are you getting this from? I'm taking it straight from here, and I'm just doing a comparison of where those numbers are compared to that form right there. And so then, ooh, can I get this all on the screen? Maybe? Maybe this first one I can. There's the form I'm looking for. So log B of A equals X. Now this one, you're not going to know off the top of your head, probably, if you've written it correctly. Unless you remember, base, exponent, answer is 14 squared 196. Yeah. It's just getting used to it. So again, there's my base. My little 3 that goes down here, don't make it a big one. Your answer goes next to your log, and your exponent is going on the other side. 14 squared is 196. 3 to the 4th is 81. And just like all the others that we've seen, the format doesn't change just because I see a fraction or a negative. There's my base. There's my answer. There's my exponent. The formatting is always the same. And for this last one, I'm going to write out all my terms again. I'm taking them straight from that form up at the top of the page. And then I'm just copying them into the log form that's up there. Log B of A equals X. I'm going to show you here in a minute how you could actually check that on the calculator. But I want you starting to get used to seeing it this way before we start grabbing hold of the electronics and having them become our brain, because that's no good. No good at all. Okay. So let's look at one more piece to this. Like, man, hard. It is day one. It is. And these are all going to go quick, which is nice. So, a log with base 10 is called a log and can be written without the base. You're like, wait, what? So, in just the same way that if you see x, we assume it's x to the first power, or if you see something with a fraction or a number, you don't see it there, we assume it's over 1, things like that. That's what the same idea is going here. If you ever just see log, it means log base 10. And so now, use your knowledge of exponents to evaluate the following logs. You're like, oh gosh. Okay, so now what do I do? After all of these, except for the first couple, let's do it this way. Because when I go to look at this as an exponent, 7 to what power equals 49? This first group will have whole numbers for all of them. So what power do I take 7 to get 49? 2 squared. Okay, we just want the number now. So 3 to what power equals 27? 3. 3 to the third. Now here, I'm not going to put the equals x, but we're doing the same thing. Remember, if there's no number here, that's a 10. So 10 to what power is 100? 10 squared. 10 to the second. Ooh, let's see if I can trick you now. Not that I'm purposefully trying to, but 12 to what power equals 1? And no, it is not a decimal or a fraction. 0. Nicely done. Let's see. Oh, can I throw a twist in? Okay, let's jump down a little bit. Ooh. Nice. Okay. So here's how this works. I got to ask myself two things. First, I'm like, okay, so 9 to what equals 81? Well, that would be 2, but I need to flip it because I need it to be 1 over 81. That's where we use the negative. If we need to flip something, whether it's a fraction into a whole number into a fraction, we're going to need the negative. So that's kind of something good to keep track of. Ooh, then the craziest one. Let me ask a different question. Four to what power is 64? 4 is a little too high. 3. Okay. Now, here's the thing. It's not 4 to the x power equals 64. It's the other way around. I'm getting smaller. So if I need to get smaller instead of a power, I'm taking it to a root. We're just going to flip that number. Okay? If you're going from bigger to smaller, it doesn't happen often, okay? 64 down to 4. 4 to what power gets me here first, and then just give it the old flip a root scheme. Or you can start taking roots of things, square root, cube root, whatever you need to do. So these two are the special cases. Most of the ones we deal with are going to be really straightforward, but those two, when we see the fractions or the smaller numbers, can get a little kooky. So don't worry about it. But here is the best news. And I always doubt whether I should show you this the first day, but I'm going to do it anyway. So now, there's this thing called the change of base formula. This is where we get to use the calculator. So if you have one that's really hard to figure out, you can do this thing called change of base, which is you are going to take the log of A, your of value, and divide it by the log of B. So here's how this works. Trying to figure out 16 to what power is 64 would be really, really hard to do in your head. Like, I wouldn't be able to do it in my head. So what we're going to do in that case is we're going to take the log of 64 and we're going to divide it by the log of 16. To be honest, the only thing that can mess this up is if you forget that first parenthesis that you need to add in. Like when you hit log, it automatically puts one parenthesis in for you. You just have to close it. And then divide by log 16. Yes, you need the log both times. And as long as you do that, you're going to get the right answer because 16 to the 1.5 power is 64. So, I mean, I don't want to guess that. That'd take a long time. But anytime I get stuck, I can do that. So, I don't know, I'll do the one below it. Log of 54 divided by log 2. Let's see what funky decimal we get this time. It doesn't say how far we're going. Let's go to the hundreds. Let's go to 2 decimal places. We don't need to go totally insane here. And so, as I'm playing with these, I want to do these last 2. Oh dear. Type in the right number, Hardy. Okay. But I do have to do them in that order. If I flip them, I'm going to get a really, really different answer. So what's that? Oh, I'm so. Oh, jeez. Okay, looking at things, didn't even see it. Sorry about that. And so even if it's a fraction or something like that, it does not change. Log of the of divided by log of the base. Got to make sure the order stays good. Ah. and that you type the right pieces in. Well, hey, we got a normal one. That's nice. Oh, yeah, because 6 squared is 36, and I need to flip it. What the heck? Okay, so you actually saw 4 different things, even though it was just little bits and quick pieces of all of them. So here's what we're going to do today. We're gonna change this up a little bit from what we normally would do. And I'll put this back up in a minute if we need it. Page 3 is it right now. I'm just making sure that is true. So today, page 3, knock them out. Try, I would say this. When you get to 7 through 21, try messing with the calculator, not using change of base to get to an answer. Like, I would say through number 15. So like 7 through 15. You can do that without a calculator. Or just kind of guessing. Don't use change of base until you get to 16. Force your brain to think or play with the calculator to try and get some of those answers. Key is up front if you get stuck, or I can help out too. But if you've got stuff like that, or you have old work to do,